Mustazur Rahman, ID 203353137, and I'm doing this thesis under supervised MD Mahruf Hassan, who is Associate Professor of Dafari International University from Department of Software Engineering. So what's the background that I am doing this research? The exponential expansion in internet use raises information security concern. Video made up 82% of all internet traffic in 2022. People also like to share videos. They shared 1200% more than links and text combined. TikTok users spend more than 1.5 hours on the app each day. 96% of people have watched an explainer video to learn more about products or services. Motivation. Videos consist of multiple frames which inherently offer more capacity for hiding data compared to individual image. Digital watermarking motivate content creator to create more video content. Stenography preserve the content ownership with imperceptibility. Context. Video stenography, a technique used to hide information within digital video files in such a way that presence of the hidden data is not easily detectable. We can use different type of technique in video stenography, like least significant bit insertion by LSB technique, transform domain technique, spatial domain technique, or motion vector stenography. Application. Why we can actually use this application? We can use this to cover communication, forensic investigation, digital right management, copyright protection and digital watermarking, and authentication and temper detection. The question is, why video stenography? The reason behind video stenography is higher capacity, temporal redundancy, dynamic content, real world application, adaptive embedding strategies, enhanced security features. Literature review. Mr. Mohammed and Jamil Ahmed in 2017 published a paper named Image Stenography for Authenticity Visual Content in Social Network. They use image stenography method and three-level encryption, and they use most significant bit detection LSB substitution and TLEA prior embedding. In this paper they have some lackings, that the embedding secret data is trigger image cannot be fully recovered if it is affected by attack. Invisible semi-fragile watermark and stenography digital video for content authentications and data hiding. Method. Transform method, DWT, DCT, SVD, using both watermark and stenography method. Anthony Rainey Guzman in 2022 published a paper named Image Stenography using Deep Learning Technique. So that's all the literature review. Now research gap. So that actually two research gap I find after I review all the paper. One is visible watermark can easily tempered and detectable, and second is data hiding capacity is very low in image. Problem statement. The first issue is only one frame is available to embedding in a large amount of data to reduce imperceptibility. And in an image, due to limited capacity, limited number of pixels is easily detectable by a first attack. And the problem is arise from this issue is traditional image selection is more perceptible, limited capacity, and easiest to attack. The issue 3 and 4 is ambiguity arises when multiple users download, modify, and re-upload the same content, making it hard to identify the original owner. Authentication and authenticity of visual content before major issue on today's social media and tech relevant platform. And this issue cause a problem too. Traditional invisible watermark modifiable and removable by attacker, and they can be pretended as their own content. Research objective: to propose a video stenography technique for embedding data in a video that is not perceptible due to huge capacity. Objective 2: to propose invisible watermark technique using stenography which preserve the content ownership, enhance and robustness. So methodology: there's my block diagram for embedding methodology. There's the extraction process. In embedding process, I actually take a video and separate the frame, then take a secret key, and from that secret key I create a hash value, and using this hash I select a number of frame, which is my own algorithm, and then I use uh, that selector frame to embed the message. And first I take the message, then it's encrypted by RSA public key, and then after encrypted it will be embedded through XOR substitution technique. And this is stego frames, and the other normal frames are concatenated, and video frames reconstructions process is going on, and the last as output the stego video comes out. And for the stego video, first I take the secret key to identify the frame where I actually hide the secret encrypted data. After identify the frames, I extract the data and decrypt it by using RSA private key, and then I got the secret message. This is the flowchart of separate key frames of secret key. This is the secret key. I take the secret key, create a hash function, which is a hash function converted binary, and where the binary number is 1, I only take those frame. If binary number is 0, I didn't take those frame. Flowchart of RSA calculation. This is the RSA calculation flowchart and encryption process. This is the exit substitution process for embedding data. Flowchart. And this is the extraction process. This is the implementation, embedding algorithm, extraction algorithm. The evolution PS and peak signal to noise, SSI and BPP and detection rate. So if I go to the code section now, so this is my embedding process code. This is the function of taking a frame and load the frame. This is the function of convert the message to binary. This is the function of to get the 7-bit for XOR substitution. This is embedded bit to embed bit in a 7-bit, and this is also a version of XOR substitution in LSB. This is the main function of embedding message within the frame pixels. This is the save image function. This is the embed message in image, and this is split in string function, and that's all the things. Frame instruction count frame, encode string, and in these things we actually encode and pass it to the functions and clean the temporary folder, and this is the main function how we call it. And this is the decode function as usual. Structure message to binary decrypt